Now, this is the graph. There are two graphs given over here, that is regarding the effect of vagal stimulation on frog's heart. So, if you get any one of them or either one of them or the both of them, because the only difference between these two is the strength of the stimulus. If you look over here, it is written F20 voltage 20. It means the frequency of the stimulus is 20 and the voltage 20 volt. And in this one F30 V30 means frequency is 30 and voltage is 30. It means we have increased the frequency as well as voltage of the stimulus. So, obviously, it will be more stronger stimulus. So, how will you know the stimulus is provided? Because see, this one is the graph you are getting, the other marking point will be either for the there will be the time marker or stimulus marker. So, in this stimulus marker, what you see, one arrow is over here, it means you have started applying the arrow. This is downward arrow, means you have stopped providing the stimulus. So, through entire in between these two arrow, what you are seeing, there is very black line. It means continuous stimulus you are providing. Starting point is this one and this is removal of the stimulus, and the frequency and the voltage we know. Similarly, in this one, the stimulus starting point and this is end point of the stimulus, but we have increased the strength. So, what you can see, first of all, you should know what is the effect of the vagal stimulation. Vagal nerve is parasympathetic. It releases the acetylcholine, and we have seen or studied the effect of the acetylcholine on the heart. What is that? Reduction in the heart rate and reduction in the force of contraction. I won't go into detail for the reason for that we have covered in the first graph itself, like it acts via the M2 receptor, reduced calcium, right. So, you should know about all these things, but in this graph we will discuss about like what the effect we are seeing. Now, before going to that point, the vagus nerve, it ends in the case of the frog's heart. If we draw the diagram of the frog's heart, let me do it. So, if we draw the diagram of the frog's heart, there was the atria, right, and then there was the ventricle. What was one more thing? One more thing was sinus venosus. So, that junction of the sinus venosus with the atria, over there will be end of the vagal nerve ends over there, and it means we can say, and it ends on the ganglia. It is white in color, that is why it is called as white crescentric line. So, it is white line, white crescentic line, that is nothing but the ganglia on which the preganglionic fiber or the vagus nerve ends. Then from that ganglia, the postganglionic neurons will go to the heart. Okay. So, whether we stimulate the vagus nerve or we stimulate the white crescentic nerve, the effect will be one and same. That is the one point. The second thing is, what will be the effect? There will be reduced heart rate and reduced force of contraction. That is, if you provide the stimulus and then just remove the stimulus. So, see, this is the point of application of the stimulus. What you are seeing, there is slowly there is reduction in the force of the contraction as well as the heart rate. If you remove the stimulus over here, then it will return back to the normal, but we have provided the stimulus, there is more and more reduction, but there isn't any stoppage. Heart rate has slowed down, force of contraction has reduced, but there isn't any much of the stoppage of the heart. And whenever we remove the stimulus, slowly and steadily it returns back to the normal. So, you can explain this graph. Now, what about this graph? This graph we have increased the strength and the frequency and the voltage. It means we have increased the strength of the stimulus. So, initially there is entirely stoppage of the heart. We keep on continuously stimulating. So, ideally it should be totally stoppage, but now we are stimulating the vagus nerve continuously. We haven't stopped, we are providing the strong stimulus, but still we are getting few of the contractions. Now, they are lesser in the rate, producing less force of the contraction, but still we are getting some sort of these contraction, and if we look over them slowly and steadily, there is increase in the force of the contraction ideally. So, as soon as we remove or stop providing the strong stimulus, again slowly and steadily it will come back to the normal, right. So, what is the reason for that? This graph you can easily explain. What about this one? We have increased the strength. So, it ultimately resulted in very strong release of the neurotransmitter. Acetylcholine is also getting released over here both, but here very high amount of the acetylcholine is released because of the strength of the stimulus is higher. So, that will ultimately stop the heart, that is vagal stoppage. Okay, that is okay. So, that has made the heart to stop over here. Now, before going to these explanation of these things, in the case of the frog, the vagal nerve is parasympathetic, we all know. This vagal nerve comes at the level of this white crescentic line, gets end over there is the ganglia, then from there the branches goes to the atria. Remember, ventricle is never supplied by the vagus nerve, either in the case of the amphibian or the mammalian heart, right? And whatever we are doing the recording, we are doing the recording of contraction of the ventricle. That is one point you need to remember to know what is the reason behind these waves we are getting. The second thing is, when the vagus nerve comes from the CNS, not only the parasympathetic heart has got the sympathetic supply too. In the case of the amphibian, the sympathetic trunk, it travels along with the vagus nerve. So, it is not the isolated vagus nerve, it is vagosympathetic trunk. So, when we are stimulating the vagus nerve, we are not only stimulating the vagus nerve, we are stimulating the sympathetic trunk too. Now, the question will arise, why when we are providing this less strong stimulus, we are getting the reduction in the heart rate and the force of contraction. Why not for the sympathetic one? Okay, let me tell you the reason for that. The sympathetic trunk, it has got higher threshold as compared to the vagus nerve. If we provide the weak stimulus, that will only stimulate the vagus nerve, right? And if we provide the strong stimulus will obviously also stimulate the vagus nerve, but after some time it will start stimulating this sympathetic trunk too. So, when in this situation, when we provide the strong stimulus, initially there is complete stimulation of the vagus nerve. So, very high amount of the release of the neurotransmitter acetylcholine, that ultimately resulted into stoppage of the heart. But after some time, by this time we are continuously providing that strong stimulus, the threshold of the sympathetic stimulation has reached. Now, the sympathetic has also started getting stimulated. So, this thing is called as, after the stoppage of the heart, this thing is called as vagal escape. It means the heart has escaped from the vagus. This is called as vagal escape. Heart has escaped from the vagus, effect of the vagal stimulation at this point, because it has started contracting. So, if we look at this thing, what is the reason for the vagal escape? The reason for the vagal escape is, one is we are not only stimulating the vagus nerve, we are stimulating the sympathetic trunk, but the sympathetic has got the higher threshold, that's why it will take some time to get stimulated. That is one reason. Second reason is, there is excessive amount of release of the acetylcholine at this point only. Continuously there is excessive release of the acetylcholine. So, by this time there is depletion of the acetylcholine. That is the second reason. And what is the third reason? I said the ventricle doesn't have any supply of the vagus nerve. Vagus nerve supplies either the atria or that sinus venosus. So, the effect is on the atria. Atria has stopped contracting, sinus venosus has stopped, not contracting, stopped generating their impulse. Now, like in the previous graph, in the case of the study of the property of conductivity, if you provide the second strenuous ligature, after some time ventricle will start generating its own rhythm. So, ventricle might have also start generating its own rhythm, idioventricular rhythm, right. So, there are the three reasons for the vagal escape. What are these three? One is depletion of acetylcholine. Second is the simultaneous stimulation of sympathetic trunk, because they have got the higher threshold. So, it will take some time for them to get stimulated. So, sympathetic fiber has started getting stimulating, and sympathetic effect is increasing the heart rate and all. The third is onset of idioventricular rhythm. Idioventricular. So, these are the three reasons for vagal escape. Now, what all kind of the questions you can get? First is like the how will you identify the vagus nerve in the case of the frog's heart, because you are not performing the action, but still the vagus nerve is accompanied by the sympathetic trunk, that is very thick one. So, that vagosympathetic trunk will be there. What kind of the fibers does it carry to the heart? It carries the parasympathetic fiber. What is the role of the vagus in the activity of the heart? Vagus nerve decreases the heart rate as well as force of contraction of the heart, that is called as vagal inhibition. And what part of the heart should be stimulated to get the same effect as that of the vagus? That is the white crescentic line, because the white crescentic line is the part of the heart. Okay. What are your observations when a weak stimuli of the short duration is given? There is reduction in the heart rate as well as force of contraction. If the strong is provided, there will be the stoppage of the heart. When the vagal stimulation is stopped after the stoppage of the heart, what will be your observation? Heart will resume to the beat again after some time. It will take some time, but slowly and steadily it will return back to the normal. Okay. And when the vagus nerve is stimulated continuously, what is your observation? The vagal escape will occur. What are the reasons for the vagal escape? We know all the three reasons. Now, the question might be, how can you block the effect of the vagus nerve stimulation chemically? Chemically means what kind of the chemical if you provide? Chemical, that is called as chemical vagotomy. Like vagus nerve stimulation effect, how will you do the vagotomy without doing any cutting the vagus nerve? Means chemical vagotomy, that is the atropine, because the atropine is the inhibitor of the neurotransmitter released by the vagal nerve stimulation, acetylcholine. Okay. So, that is all regarding the vagal nerve stimulation. Let me give you one more graph, that is also the vagal stimulation effect. One sec. This one, if you look over here, this is also the graph of the vagal stimulation. Like, see, this is the before the application of the stimulus. This is point of stimulation, and this is point of removal of the stimulus. Continuously we are providing the stimulus. So, initially there is stoppage of the heart. Okay. Stoppage of the heart, then there is generation of idioventricular rhythm, we can say the vagal escape. Vagal escape is there, and after the removal, then again and slowly and steadily at the last part of this graph, it is trying to return back to the normal. So, that is all regarding the vagal stimulation.